Hello everyone, welcome back to our channel. So, Shomo sir, interesting question today.
So it's a linear race problem, but not the very typical type. It's like it has been presented in a different angle and people might get confused how to utilize it. So let's jump into the question and let's have a read first. So we have a race of, so we have a race of 3 horses. Fair. First beat the second by 11 meters and the third by 90 meters. So basically the first line is telling us that the first horse beats the second horse by 11 meters and the first horse beats the third by 90 meters, right? So what we know is when the first horse reaches the finishing line, the second horse is 11 meters behind the finishing line and the third one is 90 meters behind the finishing line.
Correct.
If the second beat the third by 80 meters, so now it says that when the second horse reaches the finishing line, the third is 80 meters behind the finishing line, right? So you're looking for the length in meters of the race course. Remember, in a typical linear race problem, the length of the race course will be given, and accordingly we have to figure out something using the beating and whatever speed ratio and stuff like that. Those kind of things are what we concern ourselves with, right? So this is just the other way around, something like that. So let us just visualize this first. So we have, let's say this is the race course. Now there are 2 scenarios. The first scenario is when the first horse finishes the race, right? So when the first horse reaches, let's say this is the finishing line. So horse 1 reaches here. The second horse is 11 meters behind. So this should be 11 meters, something like this. And the third horse is 90 meters behind the finishing line. Agreed?
Correct.
Now there is another scenario, and that is from the perspective of the point of time at which the second horse reaches the finishing line, right? So when the second horse, that is H2, reaches the finishing line, the third horse is 80 meters behind the finishing line.
Correct.
Now, just briefly look at the 2 pictures. Which horse or rather horses are common between the 2 pictures? H2 and H3, right? In the second picture, we don't have H1.
Correct.
So the common horses between the 2 pictures are H2 and H3. So let us think in terms of H2 and H3. So what has happened from here to here? So if you think about this, from this point of time to this point of time, H2 has covered this distance, right? And that is 11 meters.
Right.
And H3 has covered from this particular point to this particular point, which is somewhere here, right?
Correct.
And this entirety is 90 meters. And this thing is 80 meters. So this gap should be 10 meters.
Right.
So by the time H2 covers this 11 meters, H3 must have covered 10 meters.
Okay.
And also in the initial situation, so let us assume for this last bit that the length of the track is some L meters or something. We have to figure out in meters, never forget the unit. So let us assume that the race course is L meters. In the first scenario, what has happened? Or we can consider the second scenario also, it doesn't really matter. In the first scenario, H2 has covered L minus 11.
Right.
And the third horse has covered L minus 90 by the same time.
Right.
We can also think in terms of the second scenario. Second scenario will be a little easier. So let us consider the second scenario. In the second scenario, the horse 2 has covered L meters, right?
Okay.
And horse 3 has covered L minus 80.
Right.
Now, see, if these 2 has happened in the same amount of time, then this should be the speed ratio.
Correct.
Also, if these 2 distances has been covered by them in the same amount of time, then this should also be the speed ratio.
Right.
So the speeds are not changing, right? So we have L by L minus 80 is equal to 11 by 10.
Right.
Now, check this out. I mean, you can cross multiply as well if you want. I mean, cross multiplying would not be tough. So let's do cross multiply only. So we have 10L is equal to 11L minus 880. or rather L is equal to 880 meters. I can show you another thing here. What is the difference between the numerator and denominator here? It is 80, right?
80, right.
Now the difference between numerator and denominator here is 1. So if I multiply 80 to the numerator and denominator, then the numerator and the denominator of both the sides become equal, or rather L 880. That is our answer, right?
Right.
So either ways is fine. So the answer is 880.
Superb, superb. So actually, the question was also interesting, but the way, without cross multiplying this numbers,
Okay,
the
yeah.
way that, so that part was also
It becomes
pretty
very
fun.
easy. I can show you a random example. So if I have something like this, so suppose x by x minus 12 or something is equal to x minus 18 by x, something like this.
Okay.
Suppose we have something like this. So cross multiplying and stuff might become a little complicated in this case, right? So observe the differences of the numerator and denominator here. That's 12. Here it is 18. So I know that if I multiply 3 to 12 and 2 to 18, both becomes 36, right?
36.
So
Right.
if I multiply 3 here and 3 to this whole thing, as well as 2 here and 2 to this whole thing, then again the numerator matches, the denominator matches. So all you have to do is just equate 3x to 2x minus 36. Okay. I'm saying 36, writing 38. So and you get the answer, right? I mean, I must have taken wrong values. But anyhow, I don't have to assume that they are positive numbers, right? So you get the answer, whatever. Yeah.
This kind of things also, helps a lot in exam. If you are able to do this kind of stuff.
This is a ratio idea. I mean, so if I have, so for example, if I have, let me show you the basic understanding. So if I have something like 1 by 3, 2 by 6, let's say 5 by 15. Actually, in terms of ratio, each of these are the same ratio, right? 1:3. But 1 is not equal to 2, right? 1 is not equal to 5, right? So the numerators and denominators are different in actual value terms, I'm saying. So if you notice the difference, I mean, 1 and 3 has a difference of 2, 2 and 6 has a difference of 4. If I have to equate that, I need to double here, right?
Correct.
So doubling this and doubling this makes it equal, isn't it? Similarly, I mean, you can compare, let's say 2 and 6 and 5 by 15. When 2 and 6 has a difference of 4, 5 and 15 has a difference of 10. If I multiply, let's say 5 to this and 2 to this, both becomes 20, right? So multiplying 5 here and 5 here, multiplying 2 here and 2 here, I get the same numbers, right? And by the way, this not only works with difference, it works with sum as well. So for instance, if I have the sums here, so I'm just showing by these two only. So 1 and 3 has a sum of 4, 2 and 6 has a sum of 8. In order to make that equal, I need to double this, right? So if I double this and double this, I again have an equality of the numerator and denominator respectively, right? So the idea is to eliminate the variable. So for example, why did I take the difference here? Because L and L is the same sign in terms of L, right? Both are positive. So if I take a difference, the L will disappear, right? Instead of that, if I have a relationship like this, suppose x by 12 minus x and 18 minus x by x, these two are equal. Now here, difference will not work because difference will keep the variable, right?
Right.
But if I work with the sum, so the sum here is 12 and the sum here is 18, I can apply the same approach.
Correct.
So either with the differences or with the sum, it really doesn't make any difference. It's a basic ratio idea.
It was really interesting.
Yeah, this is fun. Yeah, so that's it for this particular problem. A little extra footnote kind of thing to add to the problem.
Thank you so much, sir.
Thank you, Asha. Thank you, everybody.
Thanks everyone for joining in.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.